All right, so one important skill that you're going to need for the AP exam is knowing how to write half reactions. And to do that, we're going to take it one species at a time and first figure out all the oxidation numbers like we did in the first lesson. And then we're going to split it up into the species being oxidized versus the species that's being reduced. And sometimes these examples get more complicated, and so you need to be sure that you're keeping any associated species that aren't part of the oxidation reduction reaction, but you still need them to make your equation balanced. So once you've got your equation balanced with respect to your elements, then you add electrons to balance it with respect to charge, and then you repeat that for the reduction half. So for example number 1, we're going to start by finding the oxidation numbers on all the species. And sodium and chlorine are both elemental here, so they're going to have oxidation states of 0. Then when we get to the second half, we have ions, so the oxidation state is going to be the charge on the ions, +1 and -1. Now it's pretty easy to tell that the oxidation number on the sodium is increasing. It's going from a 0 to a +1. So that's going to be our oxidation half reaction. So we take those elements, and beforehand we have 2 sodiums, and afterwards we are yielding 2 Na plus ions. So now this is balanced with respect to elements, but not with respect to charges. Beforehand it's neutral, but on the product side we have these 2 positive charges. So to cancel that out, we're going to place our electrons on the product side and balance those 2 positive charges with 2 negatively charged electrons. Now our equation is balanced with respect to sodium and total overall charge. We just now need to write it in lowest terms. All of these coefficients are divisible by 2. So we're just going to divide everything by 2, and our half reaction will be sodium yields sodium plus ion and gives off that electron. Now for our reduction half reaction, we have chlorine going from a 0 to a negative oxidation state. So again, starting with just the elements, we have Cl2, and on the product side, 2 Cl minus ions. Now here, the reactant side is originally neutral. The product side has 2 negative charges. So to get everything balanced out, I'm going to place my electrons on the reactant side, and we're going to need 2 negatively charged electrons here in order to balance the charges. And we have a -2 charge on the left side, -2 charge on the right side, and everything is good. And there we have our reduction and oxidation half reactions. For problem number 2, we're going to follow the same idea. First, just assigning the oxidation states. This ion is +2, elemental aluminum is 0, elemental iron is 0, and elemental aluminum is +3. Now, in terms of what's being oxidized and what's being reduced, aluminum is going from 0 to +3, so that is our oxidation half. In terms of the elements, we have 2 aluminums, each with a 0 charge, and then on the product side, 2 aluminums, each with a 3+ charge. So on the reactant side, we have 0 charge. On the product side, we currently have 2 times 3 positive gives us a +6 charge. So to neutralize that out, where our electrons are going on the product side, and we're going to need 6 of them. Now we have 6 positive charges, 6 negative charges, everything is neutral, but we can reduce these, everything here is divisible by 2. So to reduce it, we'll say just 1 aluminum yields 1 aluminum 3+ ion and 3 electrons. Beautiful. Now for our reduction half, we're looking at iron, which is going from a 2+ to a 0 oxidation state. And I'll do this over here. We're starting off with 3 Fe2+ ions. And on the product side, we have 3 Fe neutral. So now we have our positive charges all on the reactant side and the product side being neutral. So to balance that out, I'm going to need, again, 6 electrons. Now we have 6 negative charges, 6 positive charges on the reactant side, and neutral on the product side. And these are all divisible by 3, so our final half equation is going to be 2 electrons and just 1 iron atom, yielding just 1 neutral elemental iron atom. And there you go. Now for the last one, this is where it gets a little bit more complex, but we're going to start off just the same way. Now we know that oxygen always has a -2 oxidation state, which gives us -14 coming from the oxygen. We need a total of -2 because the charge on the ion is 2 negative. So that means that each chromium is going to have to provide a +6. Hydrogen, this is an ion, so it's +1. Iron is neutral. Over here, chromium is +3. Hydrogen bonded to a nonmetal is +1. Oxygen is -2. And these ions are +2. So we can see here that the chromium is being reduced from +6 to +3, and the iron is being oxidized from 0 to a +2. So we'll start with the iron, that oxidation reaction, and we have 3 neutral ions producing 3 Fe2+. So this is pretty much the same as the opposite of the iron reaction in the last example. We need our electrons here to balance the charges, and 3 times 2 is +6, so we need 6 electrons. And you can reduce the coefficients on that. So that took care of our iron, the reactants and product side. Now our second half reaction is going to be a little bit more complicated because we notice that the chromium is what's actually being reduced, but the chromium in the dichromate ion is connected with the oxygen, so we also need the H2O to balance out the oxygen, and then we're going to need the hydrogen ions to balance out the hydrogen from the water. So all of that is going to be in my oxidation half, or my reduction half reaction. So we'll start it off the same way. Cr2O7, and that has a 2- charge, plus 14H+, and that's going to be yielding 2 chromium 3+ ions and 7 waters. Now, in terms of balancing charges, we have 2 negative and 14 positive, so it's +12 on the left side, and 2 times 3 is +6 on the right side. So in order to balance out the charges, we're going to need to place our electrons on the left, and to drop from 12 to 6, we're going to need 6 electrons. And now there's nothing to be reduced, so that is our oxidation, our reduction half reaction.